Why would it not be for everyone? Why would it not be for everyone? I don't know either. That's why I was trying to understand your question. What? Yeah, that could happen. We might, who knows? Could snow a lot tonight. All right, so that's not the correct calendar. Just everything shifted to the right one. Listen, please. I gave you a review sheet on surface area. We've only touched surface area. We're going to do another day of surface area today. We're going to get another shape today. We're going to get another formula. Unfortunately for you, in this chapter, we get a shape every single day. Every single day we get a shape. And unfortunately, we have three different things. We got an area, two-dimensional shapes. We got volume, three-dimensional shapes. And now we're on surface area of three-dimensional shapes. And for a lot of 8th grade students, maybe not half, but somewhere between a third and a half, it becomes very confusing, right? They recognize the shape because, you know, usually math teachers try to jam it in your head really hard, myself included. And then you get lost on the fact of, wait, is it volume or is it surface area? So we're going to do cylinders today. You've already got one formula for volume. You're going to get another one for surface area. It is not the same formula. It's got some similarities, but it's not the same. All right. What keeps your head above the water in this entire chapter is that you have a great resource card so that when we come to the test, all you have to do is just identify the shape. Hey, it's a cylinder. And then read the question. What do they want? Volume or surface area? Oh, they want volume. Okay, you look at your resource card and it has the formula for volume. This homework tonight. And then if it asks for surface area, you go to surface area. The other thing that helps on a resource card is you have at least one example so that you're not lost, or maybe a quick note to yourself of, oh, by the way, on cylinders, we got to be careful because he might give me the diameter, he might give me the radius. All right, heads up. So you guys technically owe me 2 pieces of homework today. One from Friday, which was 9-7A, and then I call it the water pipe day homework. Now, some of you may, if you sent me a message on Teams, hey, do you want me to submit it online? I said no, but I know some people did. So either one is fine. If you submit it online, I won't have it in the grade book until Saturday because that's when I grade my online learners. But all I need is for you to drop as much of your homework as you got. If you got both of them, drop them in. If you got one of them, drop it in. That's fine. Yeah. The other homework was, yes, it doesn't say 9-7A. It said assignment on it because I do this stuff. Yeah. It should either say 9-7A on it or it should say water pipe day. Yeah. Yeah. What, Genevieve?
When you turn it in, since there was a first Friday.
You could turn it in by Friday. It's fine.
And was it a worksheet?
It was. I'll hand it to you in class. By the way, you're going to have to watch the video or see me for student advisement because the formulas are different. Yeah.
Can I go check in my locker?
Sure. Woe unto you. Just toss it on there. It'll be fine. Woe unto you if you show up on test day without a calculator. I will not be giving out any calculators. You will be doing everything by hand. So
what day did you return this in?
that was Thursday, so that turn it in.
I'll turn in the other 2 tomorrow.
All right, keep the noise down while they're collecting the stuff. Going back to calendar real quick. We only have today's, which finishes up sort of. There's one shape. I said before, 9.8 is on spheres. They do both volume and surface area on volume for spheres in one day. I don't know why they didn't just throw it in the other way they did the other ones, but they didn't. So it's not a big deal. It is the ugliest of the ugly formulas for all of them, for both surface area and volume. Jaden, keep the noise. Stop. Just turn the volume off. I'm trying to talk. Okay. All right, back up here, everyone. Because this is a crazy, complicated chapter, we're going to have 2 review days. Both review days, I have the option of like doing it half one day, half the other day, or doing everything in one day. I generally choose, and I will for this one, to always give you a full review. Okay. meaning that on Thursday, you're gonna get the whole darn thing. It's gonna look just like the test. Okay, look just like the test. And then on, these are shifted back. So on Monday, we will do exactly the same thing. These are all shifted one day over. Okay. And then we'll start chapter 10. Have attention. Okay. All right. We will talk. All right, here we go. I said there's only one shape today. I will do a quick general review of what we've done so far for surface area, not for volume, on the other shapes. The whole section is called prisms and cylinders. So we did prisms on Friday. We're going to do cylinders today. All right. We started off by the idea of this thing called surface area by, is there something wrong with that desk? Yeah. That's the desk that causes everyone to look in their lap. I know, you sit here now, you don't do it, but like he's doing literally exactly what you would do. All right. I'm sorry for getting us off track there. I started off this idea about net. Remember, this isn't a math word, but we talk about the skin of the object, right? The skin of the object is on the surface. And so that's not a mathematical term. But we talk about the surfaces, right? Sometimes you have flat surfaces, sometimes you have curved surfaces. Okay. Flat surface, sometimes you have curved surfaces. And what we talk about is what is the area. Another way some math teachers talk about this is if we had to paint the object, well, how much paint would it take to cover it? Paint doesn't go on the inside, right? Unless you're a 6-year-old and you eat paint. Yeah. Paint doesn't go on the inside, it goes only on the outside. That's the idea of surface area. When you or your mom and dad decide to paint something, when you figure out how much paint you need, you're calculating surface area. One tool of showing you either where the calculation comes from or to do the calculation is to make what's called a net. And a net is what it takes the skin of an object and lays it flat on a surface. And we made these, and this is kind of the picture. If I peel the skin off of that rectangular prism, I wind up with 6 sides of that rectangle prism. And there's more than one net. This isn't the only net of a rectangle prism, but here's one, and that's the one that I chose to use on Friday. That kind of gives you the idea. Now, if we were to take this net and place dimensions for each one of those 6 sides, here's a triangular prism, we could actually calculate a very long method. We could actually calculate the surface area of it simply by calculating the area of each one of these, in this case, 5 shapes for the triangular prism. Boy, that sounds like a lot of work. So in the class on Friday, we went through a long process to turn this into basically 2 shapes, one long rectangle and 2 triangles. And that's where that formula comes from. For the surface area of a rectangular pyramid, rectangular prism, it turns into one long rectangle and 2 small rectangles. And that's where these 2 formulas come from. So last class we did prisms, both rectangular and triangular prisms. Today we're going to do a cylinder. All right, so let's talk about it. Box 1, cylinder, surface area of a cylinder. Step number 1 is we got to draw the net of this. All right, what's the net of a cylinder? Say again? Well, we can clearly see it's got 2 circles. That's the easy part. What's this thing? Why would it be a rectangle?
We stretch it out.
Can you imagine me taking a pair of scissors and cutting along this side right here and then laying it flat? That would make a rectangle. So you would get basically, well, you'd get a net that would look like that. If you roll this back, right, you'd get back into your cylinder. And that's the surface area of a cylinder. So surface area of a cylinder is made up of and 2 circles. That's it. Well, I know how to calculate each one of those individually. So the area of this is, well, length times width, and the area of the circle is pi r squared. Okay, so, but there's 2 of them, so it'd be 2 pi r squared. So here's the deal. The circle's no big deal. Pi r squared, there's 2 of them, so 2 pi r squared. But the rectangle is the problem. We know the area of a rectangle is length times width. Well, the width right here, well, that's pretty clear. That would be the height. What is the length of this rectangle? Okay. I mean, I see where he's getting that, right? This is part of the circle, right? So what is that dimension, though? Well, where does it come from on the cylinder itself? It comes from that, right? Because that's what's rolled out. So what I'm doing, my finger, e-learners can't see this, but I'm going around the edge of the circle. What is this dimension? That is the circumference, okay? So it turns out that rectangle is going to be circumference times the height. Don't write down anything yet, okay? We're going to put it all together. So the surface area of a cylinder, well, the net is a rectangle and two circles, would be the rectangle plus the two circles. Now the book goes in and they give you the most unuseful formula ever, right? Here's the formula that they give you there. They say the lateral area, that's the rectangle, plus two bases. Okay, great, that's true. Now it doesn't help me do the calculation. So let's turn this into something we can use in our calculation. The lateral area is that rectangle. We said it's going to be circumference times height, right? But what's the formula for circumference? Pi d or? No, that's area.
Pi r2.
2 pi r or pi r2, okay. 2 pi r, right? So the surface area is going to be length times width of the rectangle plus 2 of the circles. We know that the length is circumference, so the length is 2 pi r or pi d, right? And then the height is the height, so tack on a height. This is what the most useful one. So 2 pi r h, that's the rectangle, plus
2 area, so
2.
2 pi r squared.
Write it down. Box 1, surface area. SA stands for surface area. 2 pi RH. You could do 2 pi d if you wanted to. Oh, I'm sorry. If you're using pi d, then it's not 2 pi d, it's pi dh. I've never actually seen any math book that uses that formula. Everyone uses 2 pi RH. Why? Because if you got a d floating around, you got a d over here, you got an r over here. Just easier to have r's in your formula. So 2 pi RH plus 2 pi r squared, but you could use pi d, so it'd be pi dh plus 2 pi r squared. Too complicated. 2 pi RH plus pi r squared, 2 pi r squared. Are you going to forget this? Oh, heck yes, you're going to forget this. I do know that on the state test, the CMAS test, this is one of the formulas they have on the 8th grade formula sheet that they give you. So luckily, you know, once you see it once, it's not that big of a deal. Okay, so we need the radius and we need the height, and all the rest is just a little bit of math. Okay, 2 pi r h plus 2 pi r squared. Is a radius or diameter? If I give you the diameter, you must divide by 2. Not the whole answer by 2. You got to plug in the radius, not diameter and then divide by 2. You got to plug in the radius. So we plug in all those numbers. Radius is 3. The height is 4. 2 pi r squared. Radius is 3. PEMDAS, what do we do first? Okay, so 3 squared is? And 9 times 2? 18. So that's going to give me 18 pi. 3 times 4? 12. Times 2? 24. All right, so 24 pi. Now, here's the deal. No, we're not going to be doing this by hand tonight for homework, but you might be asked to do this calculation by hand. And it's painful doing it by hand, right? It's painful because of this pi right here. So if you're ever asked or forced to do this by hand, don't multiply by pi until the last step, or second to last step, I should say. So notice multiplication is commutative. We can multiply this in any order we want. If you multiply 2 times 3.14, you start off with a decimal, and then all the rest of your calculations involve a decimal. If instead we multiply 2 times 3 times 4, 2 times 3 is 6 times 4 is 24 pi, and we already said this was 3 squared was 9 times 2 is 18 pi. We get that, Jackson.
A little bit confused.
On? I plug in the radius and the height.
Yeah, I got that.
Okay. By PEMDAS, we have to do exponents first. 3 squared is 9. And now look, all I have is multiplication and addition. So I'm going to choose to multiply in whatever order I want to. I'm going to multiply 2 times 3 times 4 first, just to make my life easier.
Would it be plus 2 times 3 times 4?
Not plus, if I'm covering that up, that's 2 times pi times 3 times 4. Since multiplication is commutative, it is my choice of the order that I multiply. I'm just choosing not to multiply by pi. You'll see why here in a second. Hey, any decimals so far in my answer?
No.
If pi was a variable, well, then you just add these two things together. By the way, pi is not a variable, but in this case, it acts like a variable. 24 and 18, so I get 42 pi. In higher level math, that's the answer. When you get to high school, that's the answer. You want to know why? Because it's an equal sign. It equals 24 times pi. But in 8th grade, they want you to actually multiply by pi, but we got to round. In high school, we're going to continue and do some other math with 24 pi. But in 8th grade, yep, they want you to multiply by 3.14. As soon as we do that, it is no longer an equal sign. It is approximate. Tonight for homework, they will tell you whether, I believe it's rounded, there's 10. Yes.
So would you do like the 2 times 3 times 4 plus
Attach a pi.
the pi plus
2 times 9 is?
2 times 18?
And that's where this 18 came from. And then I'm adding 24 and 18 to get 42. What I'm doing is I'm putting off multiplying by that ugly number pi till the very end. Yeah. Well, the point is this. If you're asked to do it by hand, if you follow what it says right here, we do multiplication from left to right, you got a decimal number after you get do 3 squared. Then you get a decimal number immediately. Now, her question, Jackie's question, is more of, wait a minute, I got a calculator in my hand. So guess what my answer is? Type it in exactly the way it appears and you're done. Remember, 4 steps. Identify the shape. It's a cylinder. I got to do surface area. Write the formula, plug in the numbers, do the calculation. So to Jackie's answer, well, yeah, if you got a calculator, this is all you need to have written. You can go from there right to the answer. By the way, when you type it in, what do you get? Type this into your calculator. What do you get? How much? No, type it in literally exactly the way it appears. No. Type it in exactly as it appears. Grab your calculators. Now start typing. What's the first thing it says? 2 times pi, 3.14, times 3, times 4, plus 2, times pi, times 3 squared. What do you got? 132-ish,
Yeah.
right? Yes? Okay. So it will work. The difference is if you're asked to do this by hand, I don't want to be multiplying with decimals right at the very start. Okay? All right. Here we go. Box 3. Here we go. Let's do one together. Box 3. The formula is actually pretty easy because all I need is the radius and the height and we're done. By the way, there's the radius and there's the height. Okay? Can you screw this up? Yes, if you plug the numbers in the wrong positions, it will definitely give you a different answer. Okay? It won't make a difference whether you mix up the R and the H because it's just multiplying the two numbers together. But over here, if you square an H instead of squaring an R, it will definitely throw things off. What?
So it would be the 2 would be R,
2 is R,
and then 3 is the H,
3 is the H.
and then you do it again.
What do you mean do it again? Yes or no? All I'm doing is taking what's here in blue and plugging in the numbers.
Okay.
Yes or no?
Yes.
Okay. Now, with a calculator, at this point, you're plugging that in. If you're doing it by hand, however, and yes, I will be talking about, I mean, this is a hard calculation to do by hand. first thing you do is multiply 2 times pi. By hand, 2 times 2 times 3 would be 12 pi. 2 squared is 4, 4 times 2 is 8, and I get 8 pi. Genevieve?
On the, like, I think it was the second to last two, why isn't it a three?
Why? Because it's the radius, not the height.
Okay.
This one is 3 because it is the height, but this says plug in an R, and the radius here is 2. Okay? Hey, what's 12 pi plus 8 pi? Somebody? 20 pi. Pi is close to 3, so the answer better be close to
60.
60. All right? Did you get an answer as close to 60? 62? Is that what you guys are getting? We round to the nearest whole number. I got 63, round to the nearest whole number.
I got 62.
62 point what?
83.
So that would round to
63.
63. If I round it to the nearest whole number. Round to the nearest decimal, 62.8. What was the digit after 8?
3.
Yeah, so 62.8 if you're rounding to the nearest tenth. By the way, units are squared, they're not cubed. We're not doing volume, we're doing surface area. Who's lost? Ugly calculation, but it's pretty easy to understand what to do. All right, let's do box number 4. Kai, what's the radius?
5.
Why isn't it 10?
That's okay.
Because that's a diameter. So be ready for that if they try to trick you. So the radius is 5, yeah.
So do you want to like put it in pi or do you want to?
I'm trying to teach both things because eventually they're going to give you a problem, not on my test, but you might run into a test where you're asked to do this calculation by hand. So you need to be ready for it. And what I'm going to say is the kid that doesn't understand how to do this by hand will immediately multiply 2 times pi. And they're going to take that answer, multiply it by 5, and take that answer, multiply by 5. And they're going to say to themselves, this is a 1-hour test. It's going to take me 30 minutes to do this one problem. Or this isn't a trick, right? This is a technique of keeping pi out of the answer until the very end. And I've said that inarticulately or inelegantly. Your pi is in the answer, but it's just you're not multiplying through by pi until the very end. Yeah.
So you would do 2 times 5 times 5 times 5.
Well, how about we do 2 times 5 times 5 first? 2 times 5 is
10.
times 5.
50.
So I get 50 pi here. And on this side, I gotta do 5 squared first,
25.
times 2.
25.
25 times 2. Put your calculator down, good Lord. 25 times 2. 2 quarters. You got 2 quarters in your hand. What can you buy?
50.
Thank you.
Oh.
Not at the store I buy gum
I
from.
wish.
All right. 50 plus 50 is 50 plus 50 is 100. So we got 100 pi. Therefore,
Excuse me, I'm sorry to interrupt.
yes.
I just wanted to take a quick moment to tell you how much we appreciate you, Mr. Chartier, as well as Mrs. Garland. So class, can you do me a favor and raise them real quick? I'm going to give them both a whoop whoop on the count of 3. Ready? 1, 2, 3.
Whoop, whoop.
We appreciate you both, so please come have a snack and a drink.
Thank you.
Yeah. Yeah, you know, I know very well.
All right. Here we go. By the way, going back to Jackie's question, once that's there, you can plug that into your calculator. But just remember, everything that I did up to the very end right here, 100 pi, is pretty easy to do by hand. This only becomes, by hand, it only becomes challenging if there's decimals involved. Okay? Because this is a lot of calculations. All right. By the way, you got surface area of cylinders.
Yeah.
You did one with a radius. You did one with diameter. It doesn't get any more complicated than that. I did want to just make 100% sure, even though you did this yesterday. I bet a couple of you were like, I don't even know what he's asking me to do here because I've forgotten what I was taught on Friday. So recall that these two shapes right here, rectangular prism, triangular prism, have two different formulas in practice, two different formulas for surface area. They actually have the same formula for surface area, but just not a useful one. This is the useful formula for rectangular prisms. The P doesn't stand for, well, it stands for perimeter. So what you have to do is you have to calculate the perimeter of the base. So if you select that, the top as being your base, I need the perimeter of that sucker times the height of it times 2 tops and bottoms, because you decided that was your base. By the way, on a rectangular prism, any side can be the base. It's only on triangular prism that you're forced to choose the base, in that case being the triangle. So on that particular one, if we move on to the triangular prism, check it out. It's still basically the same formula. The difference being that the base and the height here, there's no divide by 2 because you have 2 triangles. It really is base times height divided by 2, but you have a top and the bottom 2 triangles. 2 times a half, it cancels each other out. This is why this one just says base times height. Capital P stands for perimeter. Once again, you can't choose your base this time, it's the triangle. So we take the triangle, we calculate its perimeter, we times it by its height, the distance between the 2 triangles, and then to that we add the base and the base times the height of the triangle. This is confusing, right? I mean, this chapter really has a lot of stuff. Yeah.
So is it like P times the base?
It's the perimeter. I mean, you take, in this case, the bottom one, the triangle, you calculate the perimeter, you multiply it by the height of the prism, not the height of the triangle, but the height of the prism, plus the base and the height of the triangle. And a lot of kids, they really want to divide by 2 here. Technically, you are dividing by 2, but then you're multiplying by 2 because there's 2 triangles. So in other words, the result of that is just base times height of the triangle. This is confusing because there's 2 H's floating around here. One is for a prism, one is for the triangle. It doesn't even say that on that. Okay. All right. So that is how that works. You want to do one together?
Yeah.
All right. Pick one, David.
That one.
The last one. It's the hardest one. So let's do the last one together. We'll also do one of the rectangular ones here. Okay. The formula for a triangular prism for surface area is surface area, SA, is equal to the perimeter times the height plus the base times the height. Shorthand. Okay. Perimeter, that's capital P, times the height of the prism. I had to put subnotation on my heights. It'll be height of the prism, height of the triangle. All right. For me, I literally will take my pencil and I will mark one of the triangles so I can look at it. I need the perimeter of that triangle. How many sides are marked on that triangle right now?
3.
Where do you see 3?
Combined.
You see 3 numbers on that triangle I just marked.
Oh, no.
I only see
Yes.
1.
Yes, actually, yes.
I only see 1 that's marked. That means I got to look at the other triangle to get the other 2. So if this side is 9, how big is this side? It's 4. This side is, so I got 4, 9, and 7. Add them up and we get, so the perimeter is 20. How far is it between the 2 prisms, or between the 2 triangles?
9.
I heard 3, 6, 9, what?
Oh, 9.
I hold my 2 hands to represent the triangles. How far is it between the 2 triangles? 3 doesn't, it's hard to see. It's 9. Do you see where the top triangle is? It's on the top. Here's the bottom one. It's not 3. 3 is the height of the bottom triangle. But the distance between the 2 triangles is 9. If there's one thing that will cause problems, it's this one. Your eyeball just flips around you and it's hard to do. Plus, now we go back to the triangle based on the height of just the triangle. We find the little tiny square. The base is 9. The height is 3. So it's 9 times 3. Okay. Math here is pretty easy. 2 times 9 is 18. So we get 180 plus 9 times 3 is 27. Add those two and we get 207. And we're doing surface area. Can I erase? We're doing surface area, so it's measured in square units, so we get square yards. So 207 square yards. Can I erase? All right, 207, we're claiming is the answer for this one. Yards squared. Who's got a question? What, Jackson?
So what's the formula for?
That's what we're gonna do next. All right, which one you want, Jackson? First or second? Second one? All right, for a rectangular prism, it's still SA for surface area. It equals to the perimeter of the base times the height of the prism plus 2 LWs. Boy, this one is awful too. None of the surface area ones are fun. Maybe it turns out sphere is the easiest one. And it's not that easy. All right. I'm going to pick a side. Any one of the 6 sides can be the base. Jackson, which one? I'm going to pick the bottom as being my base. And it could have been any one of the 6. Triangular one, you got to pick the triangle. All right. Can you see that rectangle I just drew? All right. What's the perimeter of it? Well, this side is 10. That side is. This side is 5. That side is. So 10 plus 10 plus 5 plus 5. So we get 30. So we get 30. Okay, here we go. Top and bottom. How far is it between those two big rectangles?
5.
Times 5. Plus the length and the width of that bottom one is 10 times
Oh, wait.
10. It's some people, because they know where the story is going, would just write 50, myself included. Yes.
What about the 2?
There's no 2 there on that one.
Oh, it's talking about the 2 with the L and W.
Oh, thank you. Point for Abby. +1, Abby. ABI. All right. I skipped the 2 and the formula says 2 times length times width. Okay. Thank you, Abby. Otherwise, we would have gotten the wrong answer there. All right. 30 times 5. 2 times 5 is 10 times 10 is. So we get,
250.
we're claiming that 250, and it's in feet, so square feet is the answer to the second one. Yes? All right. Survey says, I left erased. Did we get the right answer?
Ding, ding,
Ding, ding, ding, ding. Ding, ding, ding. Look at us. All right. Now, that was a quick review and new shapes. Are we confident with our cylinders?
Yeah.
All right, do all 3, please, and we'll call it a day. E-learners, any questions? I know you didn't get to see that scratch work there. Yes. What? You didn't miss this. Do this. Do this first, and we'll talk. Which one am I trying to trick you with? Middle one. Don't get tricked by the middle. And the one on the left. Right. Not on my left and right either, apparently. Anybody lost to get started? Formula SA for surface area of a cylinder is equal to 2 pi RH plus 2 pi r squared. Let me see if I can beat your calculators. 2 pi r h plus 2 pi r squared. 2 pi times 6 times 8 plus 2 pi 6 squared. 48, that'd be 96 pi plus 6 squared, 36, 72 pi. That's going to give me an 8. 7 plus 9 is 168 pi. That's your surface area. 168 pi.
No.
No,
What's wrong?
you have to-
Well, that's the exact answer. The approximate answer will be about 3 times that.
Wait, what?
I just wanted to show you that if you're asked to do something by hand, it ain't that big of a deal until the very last step. Yes, now I got to multiply that by 3.14.
Yes.
That's where the challenge comes, is that, well, that's where the complexity of the math equation comes from.
I have 523 because you didn't do pi too.
Yeah, multiply 168 times pi, guess what you get?
That number. Oh, okay.
Thank
Oh,
you.
on my calculator, it just gives me the pi symbol next to whatever.
Now, for those of you that are using the pi symbol, your number is going to be slightly more accurate than mine because I'm using 3.14 and you're using a longer version of pi. And by the way, both of our answers are still approximate. They're not exact. Genevieve,
I think I got something really off.
well, you got the radius is 6 and the height is 8?
Yeah.
Okay, did you type the whole thing into your calculator? Before you hit enter, I want you to always pause and look at your calculator to make sure you typed in everything correctly. You should have had 2 times pi times 6 times 8 plus 2 times pi times 6 squared.
I see what I did.
Okay, see what I mean?
Well, I did that like an extension, and I got
Yeah, but
2.5.
Kai, if you have a $100 calculator, use the $100 calculator.
I did.
Type the whole thing in.
Oh, when,
If you have the dollar calculator, you can't. Now you have to do it in sections. But don't ever let your calculator do the heavy lifting for the calculation if you're allowed to use it. And by the way, for this chapter, you are.
2, 6, 5.2.
What?
I got 5.2.
Okay. The nice thing about a graphic calculator is that I can immediately take it and I can see what you typed in. Your calculator put in scientific notation.
I can get it out of this.
Alright. See what it says right there?
Yeah.
SCI, scientific. You want it in normal mode.
I didn't.
I do the calculation again. Just scroll up and hit enter. Scroll up to the initial calculation and hit enter.
Oh, I put clears.
Good job.
Scroll up to the initial calculation.
I cleared it on accident.
Give a guy a $100 calculator. And look what happens. All right. For those of you that did the work, 528 is what I heard floating around. The middle one was about 6. I rounded mine to the nearest whole number, and the last one is 19. Are we in agreement on answers?
I got 602 for the middle one.
You got what?
602.
Okay, we're gonna go back to this conversation about pi key and 3.14. If you had said I got 430, we would have had a different conversation.
I heard a different number. I had like a 700 number. That's why I blew you.
All right, we feel confident with cylinders. I'm gonna just speak for you. If there's ones that you will get wrong on the test, it's these right here. Right, these are the ones that they are challenging. It's more challenging because you gotta find the numbers. Cylinders are easy ones. But the rectangular and triangular prisms for surface area, it's challenging calculate. It is as well too, not the rectangular, but the triangular one for volume as well too. For volume, the rectangular one is easy. All right. That was it. I got nothing else for you. So worksheet, you got about what? 10 minutes left of class? Maybe some of you can, no, you're gonna have to get this done in time. All right. We're at the point here where I want to show you answers. If you do not get these answers, right, you have issues, meaning I need to see you student advisement. Why am I not getting the right? I don't mean that, oh, why did I get this one wrong? Do a couple of them. You get most of them right and one of them wrong, well then go ahead, you find your mistake. But if you're doing these and you're getting them all wrong, then you have an issue, right? That you and I have to solve together. All right, Brecken's gonna hand these out. The second thing is I want to reiterate the fact that it's a 4-step process. Identify the shape, write the formula, plug in the numbers, do the calculation, write your answer correctly with the right units. If you leave off those 4 steps, if you just have answers, it's wrong. I'm gonna mark it wrong. I need to see those 4 steps. Clearly, the first step is not written, hey, it's a cylinder. But your second step, write down the formula. Well, that confirms that step number 1 was correct or incorrect. You write down the formula for triangular prism when it's a cylinder, well, then you never identified its correct shape. All right, any questions? All right. Yes, Joe? You get all this? Okay. Good. You're doing a whole lot better. Sitting up front. Yeah, most kids don't.
I don't like it back here.
All right, any e-learners? Donovan, no one is live right now. All right, if you guys, e-learners, have any questions, send me a chat. We only have 1 class left, and then we go to review for tests. So make sure if you're having any issues, I hear about them. All right, catch you guys tomorrow.